The Sylow theorems are some theorems in group theory that are very important in the classification of finite groups. Group theory is in fact incredibly difficult, and classifying groups is incredibly difficult because groups can be absolutely horrendous in terms of their complexity. So whatever tools we can get our hands on that help us classify groups in general are great for us, and the Sylow theorems are one of these tools. For example, suppose that we have a group and we know that the order of the group is 15. So there are 15 elements. Since 15 is 3 times 5, the best possible scenario is that G is a direct product or can be built up as the product of two groups, one of order 3 and one of order 5. Those groups, a group of order 3 and a group of order 5, those would be Sylow subgroups of G. For example, the cyclic group of order 15, Z mod 15, can be expressed as a direct product of a group of order 3 and a group of order 5. This is a subgroup of this of order 3, and this is a subgroup of this of order 5. And this is the 3 Sylow subgroup of Z modulo 15, and this is a 5 Sylow subgroup of that group. However, not every group is a direct product like this. Not every group is abelian. Not every group is cyclic. So what happens in general? So in general, what is a Sylow subgroup? If you have a group, a finite group G, such that the order of G is a power of a prime times some other number that is relatively prime to P, a Sylow subgroup would be a subgroup of G of order this power of P. So some subgroup H in G such that the order of H is P to the E, that would be a Sylow subgroup of G. And the Sylow theorems tell you how many such Sylow subgroups are there in G. So the Sylow theorems tell you a lot about Sylow subgroups of your group G. First of all, it tells you that there is a P Sylow subgroup of G. There is always at least one. Two, if there are several of them, they are all conjugates of each other. They are conjugate subgroups within G. Third, if G is P to the E times M, and NP is the number of P Sylow subgroups in G, then NP divides M, that M, the cofactor of the power of P. The number of P Sylow subgroups is congruent to 1 modulo P, and the number of P Sylow subgroups is an index of G, or is the index of the normalizer of a P Sylow subgroup in G. Great. So in any case, these conditions tell you a lot about how many Sylow subgroups there can be, and that allows you to prove things about the classification of finite groups. For example, a corollary of the Sylow theorems is that if you have a finite group of order 15, any finite group of order 15, it turns out they are all isomorphic to Z modulo 15. So all the groups of finite order 15, they are actually abelian and they are cyclic. And this is a consequence, very typical consequence that one proves out of the Sylow theorems.